So number 8, right, was your homework. I asked you to go home and try it so that we could go over it and see if we were all doing the same thing. So first of all, let's rewrite. I'm going to rewrite the equation so that we can see it. This is number 8 on our homework, and it was 2NO plus 2H2 won't let me draw an arrow. There we go. Gives us N2 plus 2H2O, right? And so the first step when we're trying to figure out, remember the whole purpose of this is we're trying to determine how much we are going to create when it's at equilibrium. So we know how much reactants we are, or maybe we know how many products we are, but we're trying to figure out how much we're going to have when it reaches equilibrium, right? And so we have to do an ICE table. So I always do it down the side. I is for initial, I is for initial, C is for the change, and E is for when we are at equilibrium. So if we read in the directions, it says that to determine the value of the equilibrium constant Kc for the reaction, initially a mixture of 0.1 molar NO, 0.1 molar NO, and 0.05 molar H2. And we also have a 0.1 molar H2O was allowed to reach equilibrium initially here. Initially there was no N2, so I'm going to put a 0 right there. At equilibrium, the concentration of NO was found to be 0.062. So they're honestly giving you one of the answers, aren't they? So that they're honestly giving you a way to check your answer. Usually the ones we've done before, they haven't given us any of their equilibrium, so we had to solve for all of them. But this time they're giving us one of them, which will kind of should make it a little bit easier for us, right? So now I need to figure out my C's, don't I? Right? Okay, so my change. I have 2 moles of NO, correct? So that means it is going to be 2x, right? Negative 2x. We're going to lose 2 x's, right? H2, again, we have a 2, so it's going to be minus 2x. The coefficient in front of N2 is 1, so that's just plus x, right? In front of H2O, we have 2, so it's going to be plus 2x. And then to figure out our equations for equilibrium, right, we are going to do, it's going to be, for H2O, it's going to be 0.1 plus 2x, right? For N2, it's going to be plus x, because 0 plus x is just, plus x or just x, right? And then 0.5 minus 2x. And even though they gave us the equilibrium for NO, let's go ahead and write it. It's going to be 0.1 minus 2x. Oh, I just didn't copy it right. There we go. All right, so now what do we do? What's our next step? We could plug it into Kc, right? Or is there another way? Since they gave us part of the problem, what can we do? Can't we, since they gave us this information, let me change my pen color. Since they gave us this information right here, can we solve for x a little bit easier? Yes. So, go back to blue. Let's solve for x. So basically, we know that 0.1 minus 2x is going to equal 0.062, right? They told us what the equilibrium concentration was. We know what the equation is going to be. So this is a lot easier. We can just solve for x, right? So basically, you're going to move the 0.1. You're going to take 0.062 minus 0.1. And then you got to divide by a negative 2. So we should get a value of x equals 0.019, correct? Now let's go back and let's look at the question. The question says determine the value of the equilibrium constant Kc. So to determine the value of Kc, we need to know the concentrations of all 4 things, correct? So now we know the concentration of E, and since we know x, what am I going to do? Plug it into all the rest of them, and I'm probably going to run a room, but I'm going to give it a shot. So basically, since we know what x is, going to erase this. Somebody remember 0.019 for me. 0.019. X is equal to 0.019, correct? All right, so let's do, for H2, we're going to do 0.05 minus 2 times 0.019. Where did I get that equation from? The equilibrium ice table, right? So put that in my calculator. 0.019 or 0.05 minus 2 times 0.019. And I get 0.012. Everyone else get the same thing? All right. For N2, do I have to do any math? No. Why? Because it's just positive x, so this one's going to be 0.019. Okay, and then for this one, we're going to do the same thing. We're going to H2O. We're going to do 0.1 plus 2 times 0.019. Okay, and then we do all the math and we get an answer of 0.1 plus 2 times 0.019. And we get 0.138. Yay! Are we done? No. Okay, so I'm going to erase some of my work now. What'd you get? I'm assuming you did 0.1 plus 2 times 0.019.
Well, I did 0.1 plus.
So I just did that again. So 0.1 plus parenthesis 2 times 0.019 in parenthesis equals 0.138. Double check. Okay, so if you need to go, that's fine. I'll put this on my website later. We have, yeah, one more step. 0.012.
Oh, I think.
Okay. Okay. So now I finally get to solve the problem once the equilibrium constant, right? So to get the equilibrium constant, we take our products divided by our reactants, right? So the concentration of H2O we just found to be 0.138 squared, right? Because there's a coefficient of 2. Times the concentration of N2, which we found to be 0.019, divided by 0.012 squared, because there's a coefficient in front of H2, times 0.062 squared as well, correct? So let's hear 0.138 squared times 0.019 gives us 0.0003618. I kept 4 just until the end. 0.012 squared times 0.062 squared equals 0.123456553. So now we can re-put this in our calculator. And we get an answer of 654. Everybody get that same answer? Alright, I may have done it wrong as well. I'm trying to go really fast. Alright, so I will check that calculation here in just a second. Let's double check it really quick. So 0.138 squared times 0.019 equals divided by yeah, I got the same answer again. Is that what? Alright, so yay, we are done. We found our equilibrium constant.